Hey everyone, welcome to The Explainer. We're diving right into some incredibly practical math today, specifically percentage increases, percentage decreases, and this really neat trick called the multiplier shortcut. Seriously, if you want to crack the code on everything from retail markdowns to shifting global populations, you're exactly where you need to be. Okay, let's dive into this with a scenario that honestly trips up so many people. Picture this. You're looking at a new TV that originally goes for $400. The store bumps the price up by 20%. But then, a couple weeks later, they hike that new price by another 20%. Now, your brain probably jumps straight to, well, 20 plus 20 is 40, and 40% of 400 is 160, so it's $560, right? Well, hang on to that thought, because we're going to see why that perfectly logical sounding answer is actually a complete mathematical myth. So, here's our game plan for today. We'll start with the real-world math, then compare absolute versus percentage change. After that, we'll calculate percentage increases, move on to percentage decreases, and finally, wrap things up with that awesome multiplier shortcut. All right, part 1, the real-world math. You might be wondering, why do we even bother turning perfectly good numbers into percentages in the first place? Well, it's all about context. It translates raw data into something we can actually use. Think about it. If a company announces their profits jumped by $10,000, is that good? I mean, if they normally make $100,000, yeah, that's a solid quarter. But if they usually pull in 10 million, that 10 grand is basically a drop in the bucket. Percentages smooth out that scale. They immediately answer the so what question, which is absolutely crucial, whether you're looking at corporate finance, data trends, or just managing your own budget. Moving right along to Section 2, absolute versus percentage change. Now, what's really interesting about this is how we choose to measure change. Let's say a train ticket jumps from $75 up to $105. The absolute change, that's just simple subtraction. 105 minus 75 gives you $30, a flat $30 price hike. But to find the percentage change, you have to look at that $30 increase as a fraction of the original $75 ticket. And when you do that, you realize that $30 is actually a massive 40% increase on the original price. The percentage just gives you the real, unfiltered story of how hard your wallet is getting hit. To get this right every single time, there's a really straightforward 3-step flow. Step 1, you just find that absolute change. Simply subtract the old value from the new one. Step 2, divide that absolute change by the original value. And Step 3, take that decimal and multiply it by 100%. That's it. It's a foolproof little formula that works no matter what. But if you're going to commit just one thing to memory from this whole explainer, let it be this. So, the crucial point is, the original value is always the denominator of the fraction. Always. Whether a number is going up or going down, you have to anchor your mouth back to where you started. It's literally the golden rule of percentages. Which brings us to Section 3, calculating percentage increases. Let's actually put that golden rule to the test with some real-world data. Back in 1960, the population of Indonesia was 88 million. Fast forward to 2010, and it hit 242 million. So step 1, we find our absolute change. 242 minus 88 means an increase of 154 million people. Now for the golden rule. We divide that 154 million by our original starting point, the 1960 population of 88 million. Multiply that by 100, and wow, you uncover a staggering 175% population increase over those 50 years. Okay, shifting gears to Section 4, calculating percentage decreases. You know, the beautiful thing about math is that the rules don't just randomly change on you. The exact steps we just used work perfectly when things shrink too. Take this great example from our source material. Imagine a library that starts out with 2,800 books. Over time, their inventory drops by 37%. To figure out what's actually still on the shelves, you first need to find 37% of 2,800. Just turn 37% into the decimal, 0.37, multiply it by 2,800, and you find that 1,036 books were lost. Subtract that from your starting total, and you're left with 1,764 books remaining. And, by the way, that leftover amount, that neatly represents the remaining 63% of the original pie. And this brilliantly illustrates the answer to that tricky scenario we talked about at the very beginning. Let's jump back to that $400 TV. That first 20% price hike is based on the original $400, right? So we add $80, bringing the price up to $480. But here is where people get trapped. That second 20% increase, It's calculated on the new denominator of $480, not the original 400. And 20% of 480 is 96. So 480 plus 96 equals $576. The final price is $576, not $560. It's a compounding change, and honestly, it catches people off guard all the time. All right, let's look at Section 5, the multiplier shortcut.
Now, finding a percentage and then adding or subtracting it totally works, but it's kind of clunky. It takes multiple steps. So I want to show you this mathematical life hack that just completely bypasses all that tedious multi-step math. Let's say you need to increase a value by 65%. Instead of finding 65% of the number and then adding it to your original 100%, you can just combine them in your head right at the start. 100% plus 65% is 165%, right? Move the decimal and you get 1.65. And just like that, you've got your single multiplier.
Let's move to and see how this builds a much faster equation. The formula just becomes original value times the multiplier equals the new value. So if you're trying to increase $275 by 65%, forget about doing it in two chunks. Just multiply 275 by 1.65 and boom, you land directly at $453.75. Just one step and you're completely done. And the best part? It works just as beautifully for decreases. Let's find the multiplier for a 54% decrease. Just walk through the logic with me for a second. You start with your full 100%, and you take away 54%. That leaves you with 46% of the original amount. Convert that to a decimal, and there it is. Our instant multiplier is 0.46. To put it into action, you just multiply the original $275 by 0.46, and it takes you straight to $126.50. Seriously, think about how much time and mental energy this one-step multiplier saves you. If you're crunching numbers in a spreadsheet or sitting for an exam, this is an absolute game changer. Okay, let's do a quick recap of the main things you absolutely need to walk away with today. First, remember that absolute change is flat, but percentage change scales based on the context. Second, and this is our golden rule, the original value is always your denominator. Third, changes upon changes compound. You can't just casually add them together. And lastly, leverage those multipliers. They brilliantly turn clunky two-step math into sleek one-step math. Before we wrap up, I want to leave you with a slightly provocative, kind of funny thought straight from our source material. If you're spending money, is it mathematically possible for your savings to decrease by 150%? I mean, think about it. Decreasing by exactly 100% means you've spent every last dime. So decreasing by over 100% would leave you with negative money. Or, as another hilarious example in the text pointed out, you'd be cooking negative rice. It really forces us to stop and ponder the logical limits of math in the physical world. Definitely something to chew on. Thanks so much for joining me on this explainer, and remember to keep questioning the numbers around you.